All right, let's talk about subsetting two-dimensional structures. So we've talked about subsetting atomic vectors and lists, which are one-dimensional structures. Now we want to talk about subsetting two-dimensional structures. First, we'll start off with subsetting a matrix or an array. Right? So the most common way for subsetting a matrix is that you can subset using multiple vectors. But you can also subset with a single vector. You can also subset with a matrix itself. Basically, when you subset with multiple vectors, you provide a vector for each kind of dimension separated by a comma. And if you leave one of those dimensions blank, you're going to get back everything in it. All right, so here is a matrix, a 3x3 matrix. I've got the values 1, 2, 3, 4, 5, 6, 7, 8, 9. The rows are unnamed, but the columns are named A, B, C. So I can say, hey, give me rows 1 and 2, comma, nothing. And that's going to give me rows 1 and 2, all of the columns. So I get rows 1 and 2, columns A, B, C. You can kind of combine either logical vectors or character vectors. So here I'm going to say, as far as the rows go, true for the first, false for the second, true for the third. Okay, so we're going to get the first and third rows. Which columns do I want? I want column B and column A. So we're going to get column B for the first row and column A for the first row, column B for the third row, and column A for the third row. And so we get this. You can say, I want none of the rows, and I don't want the second column. Okay, so here we have no rows, and we don't have the second column. Our output's basically just the column names, A and C, but no contents of the matrix itself. It's a little bit strange thinking about that, but again, here's our original matrix, 3 rows, 3 columns, and we're getting back none of the rows and not the second column. When you subset a matrix, by default, it simplifies. So if you say, hey, is my matrix a vector? It's not, okay? But if you say, give me back the first row in matrix A, you get back this 1, 4, 7 with the names A, B, C. This is not a vector. I mean, this is not a matrix. This is a vector, okay? And you can say, hey, is this a vector? And it comes back and it says true. That is a vector, and it's just a named vector with the names A, B, and C for the elements 1, 4, and 7. Okay. Remember, matrices are really just atomic vectors with a dimension attribute. So here I'm going to take the first 25 letters, sorry, Z, and I'm going to arrange them into a 5x5 grid. Okay, so here I've taken the letters A through Y, and I'm going to make a matrix 5 rows. And I can just say, so I could say I want third row, second column. So I can do vowels 3, 2, and I would get the letter H. Okay, I could also say, hey, give me, notice I have no comma at the level of the single square brackets. I give it a vector with 8 and 9 in it. Okay, I give it a vector with 8 and 9 in it. And so this treats the matrix as just a length 25 vector, and we're going to ask for the 8th and the 9th elements in that. So it looks at the elements down the columns, and so it counts the 8th element. So A, B, C, D, E is the 5th element, F is 6, G is 7, H is the 8th element, I is the 9th element. So we get back H and I for the 8th and 9th elements in that vector. You can also subset a matrix with a matrix. This is a little bit less common, but it can be done. So if you have a two-dimensional matrix, or I guess all matrices are two-dimensional, but I guess a two-dimensional array, arrays can be higher dimensions, you can kind of provide coordinates. So you can say first row, 5th column. First row, 5th column is U. Then I want third row, first column. Third row, first column, C. I want second row, third column. Second row, third column, L. And first row, first column. And we get back the letter A. So here I'm going to subset the matrix vals using this matrix with 4 rows, 1 row for each element, and 2 columns, kind of giving it the coordinates of which I want. So I want row 1, column 5, row 3, column 1, so on and so forth. Okay, and it's going to select those elements out that way. If you want to subset, say, a 3-dimensional array, then you provide it with a 3-dimensional matrix with 3 columns. So here's an array with the elements 1 through 12, 2 rows, 3 columns, 2 layers, and I can say, give me back row 1, second column, first layer. Row 1, second column, first layer is the number 3. Row 2, third column, second layer. Row 2, third column, second layer is the number 12. And we get back those elements. So here I have to provide a matrix with 3 columns. It's got 2 rows in it, so I'm going to get back 2 elements from that thing. Let's talk about data frames. Okay. Now, data frames internally, again, are stored as lists. Okay. So you can subset a data frame kind of like the way you would subset a list, but data frames also have this 2-dimensional structure, so you can also subset data frames kind of like the way you would subset a matrix. So let's create a simple data frame. We're going to call this thing DF. We've got the columns X, Y, and Z. And in column X, I've got 1, 2, 3, 4. Column Y, I have 4, 3, 2, 1. In column Z, I have A, B, C, D. So here, I can say, subset the data frame, and I give it a logical vector, and I put in a comma, so this is going to give me the rows that correspond to true for this logical vector. And the logical vector is basically take the column Y, mod 2, basically is it divisible by 2? Mod 2 equals 0, so basically is the remainder after dividing by 2 equal to 0, so is it divisible by 2? And if that's the case, then it will be true for basically the even rows of Y. So where Y is 4 and Y is 2, that's going to be true. And so we're going to get back the first row and the third row, where the column Y is divisible by 2. And we put nothing here, so we get back all of the columns. You can also subset a data frame just like a list. So single square bracket will give me back a list. And here we're going to say I want basically the train cars that are named X and Z. And so we get back X and Z, and it's a data frame, so we get back a data frame with the columns X and Z. If I want to subset like a matrix, I can put in a comma, basically all of the rows, comma, the columns X and Z, and I get basically the same result. So there's not much of a difference between this and this, but the way we have to kind of think about this is that this is selecting train cars, and then here we're saying I want to select columns. Now it's just that the train cars do correspond to the columns. Okay. Watch what happens here. So if I do data frame 1, 3, and then I put a comma, then I'm going to select the rows 1 and 3. I get rows 1 and 3, all of the columns. If I do data frame and I put in the vector 1, 3, and I have no comma after that, then I'm going to get columns 1 and 3. Okay, so there's a big difference. So back here, not a huge difference between selecting columns X and Z or comma X and Z. But here, if I say rows 1 and 3, by putting a comma here, I get rows 1 and 3. If I leave out that comma there, I get columns 1 and 3. Okay, so that's where you're going to have quite a bit of a difference there. if you have named columns, okay, subsetting by this is whereas I guess subsetting in this form where you say df single square bracket x, okay, the way you subset a list, you get back a data frame. Okay, so if you ask structure of this, you get back a data frame. Whereas if you say comma column x and you select only column x, it simplifies to just an integer vector. Okay, so there is a difference here. If you just select one column, okay, single square bracket x will give you back basically a data frame or a list, and here using the comma will simplify it down to a vector. $sign notation will always kind of simplify to a vector as well, and then using double square bracket will also simplify down to a vector. A little bit more on this concept of simplifying versus preserving. Simplifying is the idea that after you subset, it kind of changes form from either a matrix down to a vector or a data frame down to a vector, and in other cases it might kind of preserve, or you might want to preserve the fact that it's a matrix or a data frame. And so how can you kind of control that? Okay, we saw this earlier. Single square bracket will preserve names on an atomic vector, and double square bracket will simplify it in that it drops the names. With a list, single square bracket always preserves the nature that it's a list, whereas double square bracket will extract out the elements of that list and generally simplify it. When you're dealing with a factor, okay, using a single square bracket will preserve any unused levels. So here I have a factor with levels A and B, and even if I select just a subset of the factor where it only has one of the values in it, it preserves the levels A and B. If you put in a comma, right, and it feels a little bit strange, but using single square bracket 1, I just want the first element, but then I put in comma drop equals true, then it will drop unused levels. For a matrix, all right, so A is a tiny 2x2 matrix with the values 1, 2, 3, 4, 1, 2, 3, 4, and a 2x2 matrix. You can say I just want the first row, all of the columns. Okay, normally that would simplify it, but you can put in another comma there. First row, all of the columns, and then you put in another comma, drop equals false. That will preserve the matrix structure. Now you have a 1x2 matrix. So you start off with a 2x2 matrix, now you'll get a 1x2 matrix. Whereas if you just kind of use single square brackets and one comma and close it off, then it will select that first row again, but it's going to simplify it down to an atomic vector. Okay, with a data frame using a single square bracket, so here's a very simple data frame, 2 columns A and B, value 2 rows in it. Using a single square bracket will preserve the data frame if you're just selecting one column, okay, versus if you use double square bracket, you'll select that first column and it will simplify down to basically just that vector. All right, so let's look at a couple examples. So here is a data frame called MT Cars, Motor Trend Cars, and I think these are some older vehicles from Motor Trend magazine, and it has these different vehicles and it's got information. All right, so this is just kind of the first 10 rows of that data set. Okay, what happened when I said, hey, I want to select MT Cars cylinders less than or equal to 5? So let's look back. There's a column, cylinders, right? And we got 6-cylinder, 4-cylinder, 8-cylinder vehicles. And I just want vehicles that have 5 or fewer cylinders. So I want something like the Datsun 710 and the Merc 240D. I don't know what that is, Mercury 240D. Okay. And we get back error in selecting from the data frame MT Cars cylinders less than or equal to 5. It says undefined columns selected. Okay. Well, what happened? Okay. What happened was that because I left out the comma, this is going to be a big true-false vector, right? A big true-false vector. So it's going to be something like false, false, true, false, 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 true, true, false. Okay? And so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 columns. I probably have even more rows. So let's say I have a true at like the 15th row. Okay? If I have a true at the 15th row, it's going to be trying to select the 15th column, because without the comma, we are selecting columns. So it's going to be, I don't want the first column. I want the third column. It would select the third column, then the I don't know, 8th column, 9th column, and then maybe the 15th column. And it's saying undefined column selected. That's why we're getting the error. What we have to do is we have to put in the comma there, and this will now correspond to which rows I want. So now I want the rows that correspond to cylinders less than or equal to 5. And indeed, we got those vehicles that have 5 or fewer cylinders. Okay. Here I said empty cars cylinders equal 4. Basically, I want 4 cylinders or 6 cylinders. And I put in the comma. So I only want those rows. But when you look at this, I'm still selecting rows that have 8 cylinders, okay? And I said I only want 4 or 6. 4 or 6. What's going on? Okay? Well, what's going on is that this is an OR operator, okay? And it's going to coerce whatever's on the left and whatever's on the right into logical values. So the statement on the left will produce logical values. We're going to get false, false, true, false, 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 true, true, false, 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 so on and so forth. However, the right is not a logical statement. The right is just the number 6. And when it gets coerced into a logical statement, what happens? Anything that's not a 0 gets coerced into true. So basically I have this true false vector, false, false, true, false, 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 true, or whatever, or true. And so that's just going to become true for everybody. So we're going to select all of the rows. So what I have to do is I have to do empty car cylinders equals 4 or empty car cylinders equals 6. Then I have a true false vector on the left, a true false vector on the right. It's going to do the OR statement, and now I get just the rows that have 6 or 4. Okay, and I have the comma there. If I say empty cars 1:13, I get undefined columns selected, okay? And I might have been thinking I just want the first 13 rows, okay? So again, you have to remember to include the comma. If you leave out the comma, all right, it's going to try to select the 13th column. There's no 13th column, so that's where we're getting undefined columns selected. So that's important to remember and keep in mind as you are subsetting there. All right, and that's it for subsetting our 2D structures.